Okay, since I'm gone today you're going to have another video for your notes. For what you're due now, you need to go to the next clean left-hand page and write down all of this information. So you need this sentence right here so that you know what you're talking about, and you need the picture. Then go ahead and pause this video so that you can try it before I go into explaining it. Now that you've tried it, when we are looking at this, first off, you have to know that you are looking at a rhombus. So in your characteristic chart, which should already be out and on your desk, at the very top you have your parallelograms. And then it breaks into your rhombuses and your rectangles. So we are looking at the rhombus box and at the parallelogram box since it's above it. You're not going to go into square, and you're not going to go to rectangle because those are different from your rhombuses. You are looking here and then way at the top of parallelograms. We are given information about angles and specifically the pieces of the angles. So we need to look on our chart for different properties about angles in a rhombus. When you look at your rhombus properties, you see that your angles in a rhombus are bisected by the diagonals. So those two parts should be equal to each other. It's the first thing you have to figure out before you go into figuring out what you actually want to find up here, because you have to be able to find x. So I know that these should equal each other. So I'm going to set up 5x plus 1 equals 8x minus 20, and we're going to solve that. When you move your 5x, you get 3x. When you move the 20, you get 21, and so x is equal to 7. Plugging this back in, 5 times 7 is 35, plus 1 is 36 degrees. This bottom one is also 36 degrees. However, what we actually want to know is the measure of angle FED. So you have to go back to your properties chart a little bit. For one, we know that all of angle F, so this whole thing right here, angle CFE, has to be 72 degrees because it's the total of these 36s. So the measure of angle CFE is 72. The reason I go to that is because on your properties chart you have something about consecutive angles. Specifically, this is listed up in your parallelograms properties, but remember, parallelograms and rhombuses are going to be able to work with the same properties. These angles are supplementary. So if that CFE is 72 degrees, then I can find the measure of angle FED by doing 180 minus 72, which is going to be 108. So your final answer to this problem is 108 degrees, but you did have to find quite a few things before getting to that point. Go ahead and get your homework out. We are going to collect this so I can stamp it. Next class we will worry about filling in the link as well as going through the correct answer. So for now, just go ahead and collect this homework. If your title's not already there, please make sure this title is above your due now on that top left-hand side, so quadrilaterals in the coordinate grid. We are actually going to work with the exact same properties today, but we're going to do them in a coordinate grid, which means there's a few formulas you're going to have to work with. The first is going to be slope. One thing that you do have to remember is how to find slope. So if you have x1 and y1 and x2 and y2, your slope formula is where you do your rise over your change in your y's. So say y1 minus y2 over your change in x's. So x1 minus x2. Remember, what matters is that whatever you put first comes from the same ordered pair. So both of these have 1s. They both came from this ordered pair. Otherwise, it doesn't matter which one goes first. You can start with the second one or the first one. It does not matter. Make sure whatever one you start with them both. And it is always your x's over your y's. Where slope comes into account is when you are determining if your lines are parallel to each other or if they are perpendicular to each other. For example, in your parallelogram properties, you know your opposite sets of sides are parallel, so you can verify that or you can use that fact with this slope formula. For lines to be parallel, they have to have the same slope. For lines to be perpendicular, they have what is called opposite reciprocal slopes. And this is something you learned back in Algebra 1, but an example of this, say one line had a slope of 1/2. Opposite tells you to flip the sign, so it is a negative instead of a positive. Reciprocal tells you to flip the fraction, so this would be 2 over 1 or just 2. So two lines that are perpendicular could have a slope of, say, 1/2 and -2, and those lines would be perpendicular to each other, which could give you something like, say, a rectangle if you knew those were sides. What this is going to look like is problems like this. So go ahead and write all of this down. On parallelogram PQRS, if P is located at 1, -2, and S is located at 5, -7, it wants to know the slope of QR. Like usual, I'm going to go ahead and draw a picture. Feel free to pause this if you haven't written it all down yet, but we're going to draw a picture of a parallelogram. I do try to make it look like the shape we're talking about. PQRS tells you the order around your shape. So for example, P, then Q, then R, then S. You should be able to go clockwise around or counterclockwise, it really doesn't matter, but you should go in order with these letters. We know P is at 1, -2. We know that S over here is at 5, -7. So we could find the slope between these two lines. What they really want to know is the slope of QR. Looking at our properties of parallelograms, because remember the first thing you got to do is figure out what you're talking about. The shape we're talking about is parallelogram. And what part we're talking about is opposite sides. We know that our parallelogram opposite sides are parallel. So if we find the slope of PS, we have also successfully found the slope of QR. So that is exactly what we are going to do. To find the slope of PS, we're going to use our slope formula from the last slide. On top, you are going to subtract your y values. So I'm going to do -2 minus -7 on top, and on bottom, I'm going to do 1 minus 5. Remember, since I started with the -2, I had to start with the -5. When we simplify this, these two negatives go ahead and cancel out, so -2 plus 7 is 5 over -4. Since this is the slope of PS, this is also the slope of QR, so this is your final answer. Similarly to before, go ahead and write this one down and see if you can give it a try. You need all these words, you need to draw a picture, you need to label your information and figure out what parts you are talking about. If I go ahead and label this, remember it has to go in that order around the picture, so we know what we're talking about. J is at -2, 5. K is at 2, 2. Okay, this time we're talking about, we're given the endpoints of JK, and we want to know the slope of LK. So we need to know how these are related. Well, if you look at your square properties, and you look at your sides that are next to each other, these form a right angle, which means that they are perpendicular. So JK is perpendicular to LK, which means we can use our properties from perpendicular lines before. First thing you got to do is find your slope of JK. So just like before, we're going to do -2 minus 2, whoopsies. Sorry, please make sure you put your x's on bottom. So we can do 5 minus 2 over -2 minus 2. 5 minus 2 is 3. -2 minus 2 is -4. So this is the slope of JK. To find LK, we know they have to be opposite reciprocals, like we talked about, if you remember, back here, where you flip it over and you change the sign. So we're going to do that to it again. We are going to flip it over. So it is now 4 over 3, and we are going to flip the sign. Since it was negative, now it's positive. So the slope of LK has to be 4/3 if this is a square. Okay. Next thing we're going to do is talk about the distance formula. Distance formula, as you remember, will find you the distance between 2 points, which is the length of sides or of diagonals. So we are going to use this to check the length of sides and diagonals. In the event you do not have this written in your notes recently, which you have it in quite a few places, but we'll give it to you again. Remember, it's x minus x squared plus y minus y squared. what we're going to look at is a few different cases and how their lengths of their diagonals and sides are related. In a parallelogram, I want you to think about what you know about your opposite sides. Okay, in a parallelogram, as we talked about before, your opposite sides are congruent. So we can use the distance formula to verify that. You will have to do the distance of all four sides, but you can verify it. Looking at your property sheet, do we know anything about the diagonals, the total length of the diagonals in parallelograms? What you should find is that no, we don't. So if I go ahead and delete this, what you would check when you are checking the lengths of sides and diagonals is you will check that opposite sides are congruent, like I've marked, but you would also check and see if your diagonals are. If your diagonals are not congruent, then you can tell me it's parallelogram, because that's the shape where they are not congruent to each other. You would have, if you know they're congruent, you actually go further into this list. For example, in case 2. So in case 2, your opposite sides are congruent, just like in a parallelogram. But now, if you look at your property chart, our entire diagonals are congruent. So you can compare these two. If you have opposite sides congruent, you're really just seeing if the diagonals are not congruent, which makes it a parallelogram, or if they are congruent, then you have a rectangle. So you would check 6 total distance formulas for this. Make sure you are getting all these down. You can draw the pictures or not, but you do need this different case information. Next one is a rhombus. All four sides are congruent, just like we talked about before. If you look at your sheet, though, rhombi do not have congruent diagonals. So here you would check that your rhombi are not congruent. Again, you can use your flow chart to verify all of this information as we go. Last one is squares. Again, if you look at it, opposite sides are congruent. And since a square has the properties of a rectangle, your diagonals are also congruent to each other. So you would check that all four sides are congruent and that your diagonals are congruent. Again, here is in words. So if you have all four sides congruent and your diagonals are congruent, then it is a square. Make sure you have all this written down. Feel free to pause it if you need to, and then we will do a few examples. Okay. We're going to be given these vertices, and we're going to determine the quadrilateral's most specific classification between those four options. Here, and on your homework, it will clarify this is quadrilateral A, B, C, D, which is crucial for when you are figuring out the order of your information. I'm going to go ahead and just draw a generic one, because we do not yet know what it is. So A is at 9, -4. B is at 8, -2. C is at 2, -5. And D is at 3, -7. We are going to start with the sides. I personally group it because I know what my opposite parts are. So I'm going to do, for example, AB and CD and write them next to each other, because these two I expect to be the same, and these two I expect to be the same, but this will help me verify it. So when you do AB, 9 minus 8 squared, plus -4 minus -2 squared. This is going to give you 1, -4 minus -2. Remember, those cancel, so this is going to be +4. So AB is the square root of 5. CD, we're going to do the same way. 3 minus 2 squared plus -7 minus -5 squared gives me 1 plus 4, which is the square root of 5. My opposite side should always be congruent in all four shapes you're doing, so please pay attention to that. If you don't get opposite sides congruent, you most likely made a mistake. I am not going to give you things right now that do not have one of the properties. So now we're going to do AD, same exact way. 9 minus 3 squared plus -4 minus -7 squared. 9 minus 3 is 6, so the squared is 36. This should always be positive. -4 minus -7 is really plus. This gives me a 3. This is plus 9, which gives me square root of 45. Right away, what I'm thinking is that I shouldn't immediately know since not all of these are the same, that I'm either dealing with a rectangle or a parallelogram, because on your properties, those are the ones that do not have 4 congruent sides. They only have 2 sets of congruent sides. So that's what I'm immediately narrowing down in my head. But we do have to do BC just to verify that we were correct so far. So we're going to do 8 minus 2 squared plus -2 minus -5 squared. Again, these cancel. 8 minus 2 is 6. 6 squared is 36 plus 9. And so this is square root of 45. Oopsies. So from my work right now, this information tells me that I'm either dealing with a parallelogram or a rectangle. I have successfully narrowed it down from 4 options to 2 options. If we go back, again, your opposite sides are congruent, so that's why we are in either case 1 or case 2. What we have to verify is whether my diagonals are not congruent or if they are congruent, and so that's the next step. We are now going to do the distance from A to C and the distance from B to D and see if those are congruent or if they are different from each other. So, AC is equal to the square root of, let me just go back up a little bit, 9 and -4, so 9 minus 2 squared plus -4 minus -5 squared. 9 minus 2 is 7. 7 squared is 49. -4 minus -5, again, that switches it, so this is plus 1. So this first diagonal is the square root of 50, but again, I have to do both, so I now have to do B, D. Let's scroll back up to get B. 8 -2. So 8 minus 3 squared plus -7, was it -2? Minus -2, yep, squared. 8 minus 3 is 5. 5 squared is 25. -7 minus -2, those cancel and become a plus. So that is another 5, which gives me the square root of 50. So since these are the same, that's what you have to really pay attention to. In a parallelogram or a rectangle, which one's the same? This tells you that it's a rectangle. Feel free to pause or rewind this so that you can make sure you have all that done and you know where everything came from. There's a lot of detailed work here with your signs and everything, so please make sure you have everything here copied down. Your final answer for this problem is to tell me that ABCD is a rectangle. But you do have to have all that work to prove it. Okay. Oopsies, that's a little blurry. I apologize for that. Go ahead and copy this one down and give it a try. Pause this until you've had enough time to work all the way through the problem and check it. And then go ahead and restart the video so that you can see how you did. Okay, so you should have already had time to do this. If not, go ahead and pause it. QR, oopsies, is the first one that I'm going to find. QR is -2 minus 1 squared plus -7 minus -5 squared. -2 minus 1 is 3, squared is 9. -7 minus -5, those cancel, so that gives you 2, so this is 4. This is the square root of 13. TS is next, because remember I like to do opposites together. 1 minus 4 squared plus -9 minus -7 squared. This will give me 1 minus 4 is 3, 3 squared is 9. -9 plus 7 is 2, squared is 4. Yes, you have to show me all of them because you do have to verify that they are all the same. Then I'm going to do my other set of sides. So I'm going to do QT and verify that it's the same as RS, as well as check if it's the same as QR and TS. So QT is -2 minus 1 squared plus -7 minus -9 squared. Those are going to cancel. -2 minus 1 is another 3, squared is 9. -7 plus 9 is another 2, squared is 4. So far, I'm getting all of them to be the same, which is absolutely allowed. You do have to continue to verify it. So we're going to go to RS. 1 minus 4 squared plus -5 minus -7 squared. 1 minus 4 is another 3, squared is 9. -5 minus -7 squared is 4, which gives you square root of 13. So right now from our cases, we can tell you, since all 4 sides are congruent, this is either a rhombus or a square. You do not know which one yet, and you're going to check the diagonals in order to verify. You can check if they are the same or different, which will tell you what's going to be your final answer. So if we do QS first. Q, let me go get that ordered pair, is -2, -7. So -2 minus 4 squared, -7 minus -7 squared. -2 minus 4 is 6, squared is 36. These end up canceling out, so plus 0, which gives you square root of 36, or just 6 when you square root that. The last one we have to do is going to be RT. Again, I'll go up and get the ordered pair for R. It is at 1, -5. So, these I need to be able to see T. 1 minus 1 squared plus -5 minus -9 squared. 1 minus 1 is 0. -5 minus -9 is 4. Squared is 16. Square root of 16 is just 4. So these are not congruent. That is fine. What that tells you is that it cannot be a square, because in a square your diagonals are congruent. So your answer is that it is a rhombus. So we're going to go back up here. QRST is a rhombus. Without that, you have not done all of the work. You have to tell me what parallelogram or quadrilateral it may be. Okay, if you need another example, go ahead and try this one in your paper. I will get you the final answer for this one so that you can check your work with it. Once you've had a chance to attempt it, go ahead and play the rest of this so you can see if you were right or not. When you solve this, you should get that JK is the square root of 18. You should also get that LN is the square root of 18. But remember, those are your opposite sides, so that should work out every single time. Then when we do the other set of sides, you get KL is equal to the square root of 73, and that JM is equal to the square root of 73. What this tells you, since your opposite sides are congruent, but your adjacent sides are not, this is either, like the first one, a parallelogram, or a rectangle. So now you have to check the diagonals. When you did JL, you should have gotten the square root of 157. And when you did KM, you should get 5. Since these are not the same, your final answer is that this is a parallelogram. Okay, once you've tried that one, we're going to go ahead and pass out your homework. Make sure, feel free to, you can access this video on Canvas, so if you need to see it again to see any further examples, go ahead and get on there and do it, and otherwise you can have the rest of class to work on your homework.